Welcome you all. So in this video we will see about algorithms. So computer science students may heard about a subject data structures and algorithms. So everyone should know what is the importance of that particular topic, data structures and then algorithms. So this as a computer students, if you want to develop a strong career in future, then the key point is you should be very strong in this data structures and algorithm domain. So this is not only going to help you for your theory exams. So in future, if you want to crack any competitive exams like CAT, NET exams, or if you want to do any research, if you develop your career in research domain, or if you want to build your career in any top companies, core companies like Google, Microsoft, etc., you should have a strong knowledge to succeed all these. You should have a very strong knowledge in this data structures and algorithm concept. So before start your learning in this data structures and algorithms subject, not only this cannot be said as a subject, so this is a separate domain. So you should have know about what is actually algorithms. So algorithms, before that, any computer science students, so if you want to become a programmer, so the main job is to write programs. Means for a particular applications, you have to write a program for the solution. So in any engineering field, so if you construct a new product, so we cannot be able to construct it without any design. As a civil engineer, if he build any building, so we cannot be able to directly start constructing the building. So as a automobile engineer, if you manufacture any new car model, so it cannot be directly manufactured. So before that, they will do some designing. So in the designing part itself, they will design the solution according to their requirement, and in the design phase itself, they will find whether this solution will work in a more efficient way as it is expected. So in the same way, as a programmer, before implementing the solution as a computer programs, so we need to design it. So we have a requirement, we have a problem, and we should give you a solution for that problem. Here the solution is a software. So before start implementing that program, first we need to design it, and in the designing itself we need to find whether this particular solution will give the expected result in a more efficient way. So that designing part is here called algorithms. So the proper definition of algorithm is the procedure or set of instructions to solve a particular computational problem. So procedure or set of instructions. So what is the difference between the algorithm and the actual program? So as I already said, algorithms is a designing part of your project. So this is a designing part. So program is actually the implementation part. So and then algorithm. So how to write a algorithm? So if you implement any program, So the program should be understood by the computer because computer is going to execute that program. So the program should be written in using any programming languages like C, C++. So is there any specific language to write algorithms? No. So because algorithm is human centric. So programs are computer centric. That means program should be understood by the computer. So it should be written in a computer understandable language. But algorithms is for human centric. So it should be written in any language which can be understood by the human. That means here the human is actually not only the designer who is writing the algorithm, also the end user for whom we are developing this solution. So you can write it in natural English language, or you can also use any mathematical notations which are understandable by the readers. So it can be written in any human languages, or we can also use any mathematical notations. So if you write an algorithm using mathematical notations only, then it can be called as pseudocode also. So and then who can write or develop these algorithms? So a program can be written only by the programmer. So the programmer should have a knowledge on a specific programming language, either C, C++, Python, Java, or anything. So in the same way, who can able to write an algorithm means not only a programming skill. For writing an algorithm, so you should also have some domain expertise on that particular field. So for example, if you are going to develop an application related to healthcare problems, like detecting any diseases in the starting stage. So you are going to write some machine learning applications which is going to detect cancer in the initial stage itself. So in this case, you should have some knowledge on that particular domain, or you should get help from that domain expert. So algorithm, apart from that designer or programmer, so there is, apart from the designer, the domain expert should also have some role. So this is actually basics about algorithm. So this is the set of instructions or the procedure by which a solution for a particular computational problem can be developed. Before implementing it, so we need to design that algorithm, and then we need to analyze the efficiency of that algorithm. So in that algorithms can be written in any natural human understandable languages like English, or you can use mathematical notations. And for developing or writing an algorithm, apart from that programming skill, you should also have some domain knowledge too. So this is about algorithms, and once you write a algorithm, the next step, so what is the purpose of writing any algorithm before implementing it is we should know the efficiency of our solution. So we can directly implement our solution using a programming language, But suppose if after implementing that particular solution, you implement that entire project, and you find that it is not efficient or it is not giving a result as expected, then we need to redo the entire process from the beginning. You need to rewrite that program. So for writing, so for a computer science engineer, it may be it seem like a easy task. But if you develop any higher level projects that means interdisciplinary projects that you are combined with a civil engineer for building constructions, or automobile engineers for designing a car. So in this case, we cannot able to redo anything after you complete your manufacture. So it is a waste of time as well as waste of resources, money, anything. So for that, to avoid that, first we write that solution in a algorithmic format, and then we need to do a analysis of that algorithm. So analysis is based on many criteria. So criteria for analyzing an algorithms. We may analyze an algorithm based on several factors. So first and most important factor for analyzing an algorithm is time. So for a single problem, we can develop many logics to solve it. So for example, for sorting a given number, so that sorting can be done using different kind of logics. So in the analysis phase, we need to find how much time it takes your solution, how much time it takes to solve it. Time means computational time. That means the basic computational time is the time needed to complete a single instruction. That is the basic time, that is 1 unit time. So how much computational time it takes to solve that solution, that is the most important factor while analyzing the algorithm. So and then next one is space. So we can analyze the algorithm based on the space it takes to solve the problem. So space means here memory, how much memory it needs to provide the expected result. These are the two mostly or widely used criteria for analyzing a algorithm. So apart from that, we may also some other factors like power consumption. So how much power means electrical power. So power consumption. So and then in that modern era, we may use cloud related technologies. So data may be stored in one location, and your actual solution, your actual application is running in another machine. So that record data should be fetched from that cloud storage. So the network bandwidth or network transfer occurred. Which amount of network transfer has been happened or needed. So these are some of the criteria for analyzing the algorithm. But in this particular data structures algorithms domain, the most important and the most widely used criteria for analyzing an algorithm is time. So we will see with a simple example. I will explain what is actually time complexity and how the basics of how it can be measured. So the time complexity is a method to measure the time taken by an algorithm to complete. So here in time is not given as any value like 1 second, 0.5 nanosecond. The time complexity is represented as a time function. So you may hear about, you may see sometimes like big O of n, then theta of n square. So these are the time function used to represent the time complexity of an algorithm. Actually, these are called as asymptotic notations. So you may refer my another video to understand what is an asymptotic notation, what is the meaning of these asymptotic notations. Then this is the simple example for an algorithm. So this is a procedure to swap two variables a and b. Here it is not the actual program. I am not following any syntax of a particular programming language. It is simply written by using a simple English as well as some mathematical notations. So in this algorithm, I am writing one function to swap two variables a and b. Here you can use your own notations. For example, here for starting that procedure function swap, I use begin, a keyword begin, and to represent the end of that function I use end. So instead of that you can also use simple brackets also. There is no strict formatting for writing a algorithm. Or otherwise, instead of using this pseudocode format, you can only write that function using English. For example, in this assignment statement, you can write assign the value of a to the variable term, assign the value of b to the variable a. So in this way also you can write an algorithm. So here I am using some mathematical notations also. This arrow mark indicates assignment. This variable a, value stored in a, is assigned to temp. This is the meaning of that notation. You can also use any kind of notations like temp equal to a. So this also can be used. There is no restriction. But only thing is, it should convey your actual logic of your solution and it should be understandable. Now, how to measure the time complexity of this simple algorithm? As I already told you, time complexity is the time, computational time needed to complete this algorithm. The computational time means what is the number of instructions that need to be executed, and we assume for each instruction the CPU takes 1 unit time. In this algorithm, these begin end statements, they are not executable statements. So these three assignment statements are only executed by the CPU. These are the executable statements. Since all these three statements are a simple assignment statements, only one arithmetic operation is needed to complete it. That means it needs only one instruction to complete that particular statement. So we can assume each statement takes 1 unit time. This assignment 1 unit, and this second assignment takes 1 unit, and third assignment takes 1 unit time to complete. Here 1 unit means we assume your CPU takes 1 unit of time to execute a single instruction. Actual time of that 1 unit depending on the speed of your CPU. So commonly I'm taking 1 unit time. So totally this is 3. So this particular algorithms takes 3 unit time to complete this swap operation. But when you represent it as a time complexity, we cannot represent it as 3. This 3 is a constant. We use, already I told you, we use some asymptotic notations, that is in the form of time function. So it should be represented as O of 3. So all these constants can be taken as a unit time. So it can be written as O of 1. This is the basic idea of measuring the time complexity of an algorithm. Then apart from this data structure and algorithms, one more important subject or domain in computer science curriculum is design and analysis of algorithms. I will explain what is data structures and algorithms and what is the relation between these data structures and algorithm with the design and analysis of algorithms. I already told you algorithms are the solutions of a particular computational problems, and data structures are the structures that are useful to design a solution. So there are a lot of data structures like arrays, structures, linked list, stack, queue, trees, heap. So these are the structures by which an efficient algorithms can be designed. So in the data structure topic, you will study about these structures by which data can be arranged in a efficient way. That is why it is called data structure. How the data inside the memory can be arranged in a more efficient way. Efficient means time. That means how easily it can be fetched from the memory. So this is the key point about the data structure. Organizing our data in the memory in more efficient way so that how fast it can be easily fetched. In the data structure, you will study about those kind of structures by which the data can be efficiently arranged. For example, stack, queue, trees, and more that kind of data structures. So and then once you study about these data structures, in the design and analysis of algorithms domain or topic, you will study about how to design a efficient solution. Solution means algorithms for a particular problem. You will study about some problem solving strategies like divide and conquer, backtracking, dynamic programming, greedy approach, randomized algorithms approach. So these are the strategies by which efficient algorithms can be designed. And for developing or implementing that strategies, you should use a specific or most suitable data structure. So to design that efficient problem solving strategies, you should have strong understand of the data structure, because by using the data structures only that strategies can be implemented. That is the designing part. And in the analysis part, once you design that efficient algorithms using a particular or most suitable problem solving strategy, you need to analyze it. So how much efficient that particular solution in terms of time, complexity. For a same problem, you can come up with a solution that uses dividend conquer approach, or by using a backtracking approach, or by using a greedy approach. And in each approach, you may use a different kind of data structures to arrange the data. Arrange the data means storing and fetching in an efficient way. So to prove your algorithm or your solution is most efficient, you should analyze it and you should prove that your solution gives better time complexity, or means better time means less time complexity compared with other solution. So in this design and analysis of algorithm, you will use that data structures you are studying in the data structure subject to design a efficient algorithm for a solution using different strategies, and you can able to analyze it to prove your solution is efficient. Though this is the basics about or introduction about the two important topics of a computer science students: data structure and algorithm, and design and analysis of algorithms. Thank you.